Welcome back again. Today we will be talking about Unit 1.7 linear inequalities. When we are talking about inequalities, we are talking about greater than, less than, greater than equal to, and less than equal to, that you must have learned starting from 6th grade onwards. So, the another thing that we need to keep in mind is the intervals. Intervals are very, very important for accelerated algebra 2 and moving forward. So, let's take one example. For example, we have -3, 5. Now there are two different types of things. We have the parentheses and the bracket both. So the first one is called the open and the second symbol is called the close. So the open means -3 is not included, but 5 with the close means 5 is included. The inclusion is there. So I can write it as the compound inequality that x is greater than -3 but not -3, and x is less than and equal to 5. So this is called the bounded. The unbounded example is as simple as -infinity and infinity because they have the open intervals. They are always open, no matter what. So these are called unbounded. Unbounded means there is no boundary. They can keep on going forever. That is why it is called unbounded. So this is the basic understanding of the intervals. Now you are already familiar with the properties transitive, addition. Let's talk about one by one. So transitive, that means it shows the transition. So if we have A is less than B and B is less than C, so I don't need B. I can just say A is less than C. We have talked about it in great details in geometry as well. So with addition, what we are talking about, we are saying if we have two inequalities, then we can combine them. So we can say A plus C and B plus D. In the second inequality, it should be C less than D. I just rewrote it again. So my apologies for that. It should be C less than D. So that is why A plus C less than B plus D. Now for the addition of a constant, it is just balancing the scale. If you add something on one side, you need to add the same thing on the another side. For example, if we have A is less than B, so if I add C on with A, I need to add C with B as well. So the same thing goes with the multiplication. For instance, there will be two cases with the multiplication actually. So if A is less than B, and if we multiply something with A, I am multiplying with the something with B as well. For C is greater than 0, inequality will remain the same. But inequality will flip when multiplying by C if C is less than 0. The reason is this: whenever you multiply or divide with a negative number, inequality flips. So keeping this thing in mind, let's take one example and we will try to solve it algebraically, but you can also solve it graphically as well. So let's take this one. So remember, when we are solving the inequality, you are solving the way you will solve the two-step or multi-step equation. But whenever you multiply or divide with a negative number, the inequality will flip. You can try graphically on your own. Let's try algebraically right now. For graphically, you can equate the right-hand side equation separately and the left-hand side equation separately, and then see how the graphs are intersecting and how the graphs are working. So I can make the common denominator, and then I can multiply the denominator from the left-hand side to the right-hand side. That will give you 3x minus 18. If you clean this mess up, you will get the lovely answer as x is less than 3. So it is less than 3, right? So my interval will be -infinity to 3, and both are open. We are not talking about the close intervals in this case. Let's build up on this. Let's take another type of question that is called double or compound inequality. As the name suggests, compound inequality means I can write the inequality in one single statement. This is the AND case. This is not the OR case, compounding the two inequalities together. So we have this particular inequality and we are looking for solving for x. So how can we solve for x? Let's subtract 7 from all the 3. Because whatever you do on one side, you have to do the another side. So we have 3 sides here. So minus 7 with everything will give you this lovely equation. At this point, I need to get rid of 2 with x, right? So divide the whole entire thing by 2. So you will get x is greater than negative 3 but less than 2/3. Let's graph it on a number line. So remember, the symbols here or the inequalities, it is less than and greater than. There is no equal to. So it will be the open intervals. And because it's a compound inequality, they are facing each other. They are not facing against each other. If it is not compound, then they will face away from each other. We will do one problem in which the graph will face against each other. So let's take with the absolute value. Remember, with the absolute value, you will make 2 cases, a positive case and a negative case. But with the negative case, because we are talking about the inequality will flip. Positive case, the inequality remain as it is, but for the negative case, we will flip the inequality and make the right hand side as negative. And we will solve these 2 equations. Sign will change and inequality will flip. So the positive case will give you the answer as x is greater than or equal to 4, and the negative case will give you the answer as x is less than or equal to negative 10. Now if you graph it, both of them involves equal to sign, right? So it implies the close intervals, right? So x is less than or equal to negative 10. So negative 10 or anything less than that. So it is facing towards the left. For x is greater than or equal to 4, so 4 is included, and anything increasing from 4, anything more than 4 will be included. So 4 and anything greater than 4. So if you look at the graph, the 2 values, they are not facing each other, they are facing away from each other. Let's do one question related to application. So we have a scenario. So chocolates are sold at a price of $9.89 per pound. And the scale where they measure the amount of chocolate, the scale is accurate to 1/32 of a pound. I know it is a weird scale, but this is what it is. So you bought some chocolates and your bag weighs 1/2 pound and it costs $4.95. Now they are asking you how much you are undercharged or overcharged. So what is the undercharged or overcharged? So we can take, let's say the actual weight of the chocolate be A, because there is a variation because of the scale, because of the accuracy of the scale. So let A be the actual weight, and the scale accuracy is 1/32. It cannot weigh more than, it can be 132 or less than 1/32. So that defines, I can write it in the inequality. So A, actual weight minus 1/2 is less than or equal to 1/32. Again, we can make a positive case and a negative case because it involves inequality. So we can say a minus 1/2 less than or equal to 1 over 32, or the negative case will be a minus 1/2. Remember, we are making a negative case, so inequality will flip and the sign will be changed. If you solve it, you will get two lovely fractions. Fractions are your friends, don't be scared of them. And then the another will be a can be less than or equal to 1732 or greater than or equal to 1532. Now, these are two over scenarios, but what we are looking for, the under or the over price. So the price of 1 pound is 9.89 and the scale accuracy is 32, 1 over 32. Let's multiply them together. So 9.89 times 1 over 32, that will give you approximately 0.30906, which is nothing but 31 cents. Now, if I apply these 31 cents in these two scenarios, the weight, what we got with the inequality, I will get the two different prices. This will give you 5.25, and this will give you 4.64. So 4.464 is the undercharge, 5.25 is the overcharge we are looking for. So this is how you will solve all of these inequalities and non-linear equations. Bye-bye.